Okay, guys, we have seen this stuff before. Actually, recursive is something that we've already done. Remember, if you're looking for a certain term, it's equal to the prior term, right, plus the common difference. So when we had a problem like this, we could probably see what this, or we could see what this is. What's the common difference between our terms? From 1 to 4, what do we do?
Add 3.
Add 3. How about then 3 to what? What's this going to be? 7. What's this going to be? 10. It is 10. So if we were looking for this, essentially this is what we desire. We look at the prior term, n minus 1. Remember, n is just what we're looking at, so n minus 1 is the term before that. So I would look at the term before that, and then I would just add the common difference. We figured it out. It was 3. So we'd know that this term is the prior term plus the common difference of 3. So this is 7. Okay, we've done that before. I feel like we've done that.
Yeah, is that just like a different way of saying like what we did on Monday?
Exactly. Tuesday.
Yeah.
And Tuesday was arithmetic and geometry. Now we're just doing a day of arithmetic closely. Tomorrow, a day of geometry closely. So it is exactly the same. This explicit is, say, if we want to go in here and we want to find the 4th term, that's cool. But what if we wanted to find the 91st term? Do you feel like that would be kind of hard to do with the way we know how to do it?
Yeah.
Probably would get kind of hard. So when you're just looking to find the term, you can find any term as long as you know the first term and you know your common difference. So that's kind of the key with this. We're going to look at this as, this allows us to find, what is the 90th term way over here? What's the value of that? Okay, so it's a little different. It's not super tricky though. So let's look at this. Let's see if we can find, in this case, just the 4th term. So we want to find the 4th term, a sub 4, right? Term 4. And that's going to be equal to, what's my first term here? A sub 1 is 1 plus, and this is the thing, if I'm looking for the 4th term over here for n, I'm going to put 4 minus 1. And then let's look to see what is our common difference between 1, 3, and 3 to 5. What are we doing? Plus 2, right? So I'm going to put my d outside this parenthesis right here. It gets really quick, actually. Let's see. We just have to combine these terms. 1 plus 3 times 2. 1 plus 6. 7.
Wait.
Let's see what we did here.
I don't.
Parentheses, PEMDAS. What do we do first? Parentheses. 4 minus 1? 3.
Oh.
Then PEMDAS. Do we do addition or multiplication first? Okay. Multiplication. 2 times 3, 6.
Oh, okay.
Then we do addition, 7. Okay. It's going to be a little practice of PEMDAS. Write that up there at the top of your page if you don't know. This is PEMDAS work. Okay. I want you just to have that ready so you remember. Parentheses, exponent, multiply, divide, add, subtract. You got to do it in that order or it gets all messed up. All right, and we could have figured this out anyway, right? We could have figured this out because it's only the 4th term. But if this was the 100th term, we could do the same problem right here for the 100th term and find that just the same method.
Wouldn't 4 just be 100?
4.
No, would you switch?
Instead of 4, it would be 100. We would in that case look for a 100, the 100th term. Okay. But we'll do that maybe we'll change up one of our example problems and try that. Okay. We're going to do a couple more examples like this, but I want to show you what we already know here. I should have put recursive first, so just so you know. That's new, this is what we've already done, but you're going to have to do this when you want to create an equation. Okay. So, but for this one, let's see. We're going to take the desired term, which is our 3rd term. We're going to then look at the prior term, 4, plus my common difference between here is plus 3, so I'm looking at plus 3. So we know that a sub 3, oh, this should be equal. I'm sorry. This is right here, equal. Equal.
Then wait, what happened to the a sub n minus 1?
Oh, I see. What this is saying, if I'm looking for the, say, 3rd term, n minus 1 is the 3rd term minus 1. It's the one before it. So we're looking at a sub 2, which I then put in right here.
Oh, so you're just looking for...
Yeah, I'll put it right there just to remind us. I'll put this right here just to remind us. So you just have to plug those in pretty carefully, and that's how we're going about it. Okay, so we'll create an actual equation over there. I think for the last one, right?
No, this is first.
Here it is. Okay. So let's look at these two examples, and I'll set you loose on some classwork. With this one, we're given this sequence, right? We use these brackets to show those are terms in our sequence, and we want to find the 10th term. So this is pretty good. This is like where, and you know what? Do we want to find the 100th term? Do you want to try it?
Sure.
All right, let's do the 100th.
How about the 1,000?
Simon says 1,000. What do you think?
10,000.
Why do you keep getting 100, Aaron? 100.
Okay.
10 million. It's too early for that. We don't need to know that term. All right, we have the sequence here. Let's look to see, since we're finding, find the term, we need to know the first term, we know it. We need to know the common difference. What is the common difference between these? What are we doing between these?
You're adding.
Times or add?
It's by 6.
Yeah, it looks like we're adding. Plus 6, plus 6, plus 6, right?
Mm-hmm.
Okay. Because we're doing arithmetic sequences, it's going to be addition. Tomorrow's going to be when we have to multiply to get between each number. All right, so let's look. We're looking for a sub 100, and that's the first term. What's the first term in this? Because I need to go a sub 1.
Oh.
A sub 1 is?
3.
3.
And then plus 100.
Good.
Minus 1.
Minus 1.
And then
times 6. Who doesn't like that 6 on that side? Who doesn't like that? It doesn't make a difference. Watch. If you like to have it in the up here, that's fine too. 6 times that. You could think of it like that. It doesn't matter.
You're still multiplying.
You're still multiplying. Actually, what we're doing anyway is we're going to simplify inside the parentheses. So, I'm gonna leave it on the right side, but I'm just trying to point out it doesn't matter. And this is n minus 1. So that's where we plugged in everything. Now let's see. The 100th term looks like we're going to get it pretty quick. 3 plus 99 times 6. 3 plus 594. 587. Look how easy that was. How long would that have taken you to write out 100 terms?
Depends how fast my hand is.
But I mean, it's going to take at least a few minutes, right?
Yeah.
Okay, so we just did that in like 30 seconds. So it allows you to look at any value you want way out there in the future, way out there as the sequence gets bigger. We just found the 100th term pretty quick.
Is this the easiest way you can solve that?
Yeah. It's the easiest, quickest way.
Because there's also other ways to do it.
You can combine a few different ideas to try to find it.
That just makes it more complex.
Yeah, I mean, there's always fancy ways you can use I don't know. You probably try using summations and factorials. There's some weird stuff you can do, but actually I don't know if that would work. This is how we're approaching it. This is how Math 1 at least has us approach it. Okay. All right. So now this next one we want to create an equation. Actually, I'm going to grab my notes for this one. Make sure I get it for you. Perfect. So first off, I want you to look at that and tell your neighbor what is the common difference for that. What's the common difference? So what is the value that is applied to each term to get to the next term?
I told you.
Okay. All right.
Did you really?
What did you say?
Minus 7.
Minus 7. So we minus 7 to minus 7. This looks like it's common. Good. So you know our d is negative 7. Now, in this example too, is it asking us to find the 30th term? No. It's asking to what? Make an equation. So when you're making an equation, essentially you're setting it up like this. You're going to go, all right, I don't know what term I'm looking for, but if I set up my equation, I could then look for any term because I'd have an equation set up for it. So let's see. We have our first term is 8 plus. I don't know what term I'm looking for, so I'm just going to put it in as n, negative 7 on the outside. Okay? You see how there's a variable there. And that's going to allow us, actually it's essentially 2 variables there. We got a sub n, and we got n. So let's go ahead, and I want you to just keep in mind that when we get to the n value is going to be our x, the a sub n is going to be our y. It's already kind of set up like that, because we usually put equations where it's y is equal to something.
So that's the equation?
No, not yet. We can do more. What can we do?
N minus n.
n minus 1, we can't really combine those terms.
Multiply -7.
There we go. So we got 8 minus 7n plus 7. Combine your terms, and you have a linear equation. Watch.
8.
Positive 8, positive 7. What does that give us? Kind of faded there. What?
Positive 15.
Okay. You see how now it's kind of like a linear equation? We just have to, since we're making a function here, we have to just change, okay, this is going to be the output when I input some value for n. So I can just keep it in my traditional x and y, and there we go.
Okay, to make so the equation is using explicit. Or
X plus 7?
no, explicit like the formula explicit.
Correct. Correct. So when you're creating an equation, find it. Well, one second. No. Oh,
Yeah, it is explicit.
it doesn't. We can create an equation with either, so this is kind of misleading. I want you to put it here and here. You know what, though? Let's see. Recursive is just what we've done before. It's more of the simple. I want you to make an arrow over to this side as well. We use explicit to find a term we want, but if we don't have a term we want to find, we just leave it like this, so we could find it as an equation. Okay, I wrote it in the wrong place. Thumbs up, sideways, down for now. Feeling okay with it? Yeah? Okay, okay. Let's see if we can do one more and see how that leaves us for the classroom. All right, here in this case, we're given a recursive formula. Here it is. So it's saying the desired is equal to the prior term plus 5. We know the first term is 29. Fill in the sequence. So go ahead and fill in where 29 goes. Where does 29 go? And then you have pretty much the recursive. You can write it out if you're showing your work. Okay, this is A1, A2, A3, A4, A5. We got 29. Now watch. If I want to find A sub 2, I look to 2 minus 1. I look to basically the prior, which is 29, plus 5. That's going to give us our A sub 2. You can make your lines like you're showing your work really quick this way. So watch. This is my D value. So I add the D value to the prior, and I get 34. I want you to do the same thing. And this is like not a lot of work actually to write out. You're going to put the prior, you're going to have it plus 5, and that's going to give you your A sub 3. So keep doing that all the way until you get to A sub 5. Right, so watch. What I just found was my A sub 2 was the prior plus the D. So I just figured out that A sub 2 is 34. A sub 3, what am I going to put here, Dan? There you go. You got it. Keep going. Not bad, right? I mean,
it's easier than any of the other ones we've done.
Nice. I like that. What part of it makes it easy?
The fact that it just gives us what we need to do, and you just plug it in. You just plug in what we need to do.
Yeah. And a lot of it too. We could do this, right, without even plugging it in. We know the D. What's our D? 5, right? So, you know, this would be the shortcut way to do it. I do want you to show your work, because what's this going to be? 39. I know that's just plus 5. So what I think also makes it easy, you have the equations to look at, but you also, you just have the sequence that you kind of could figure out deductively anyway. You know what I mean? Yeah. So let's see, what's A sub 4? 39.
39 plus 5 equals 44. And then A sub 5 is equal to 44 plus 5 is 49.
Okay, just because we have this here, last challenge is, I want you to find A sub 1,000. Just for Simon. That's for Simon, man. A sub 1,000. So we're going to go over to this, the desired. We're going to use this one, A sub 1,000. It's going to be equal to A sub 1 plus 1,000. That's 1. Looks like our D is 5. All right. So go ahead and see what 1,000 is. Now, how long would it take to do 1,000 terms?
A lot. A long time.
That's like 20 minutes, and then your hand falls off.
When you mean a sub 1, that's just plugging in the 29, isn't it?
A sub 1 is always the first term.
Okay.
So A is the term 1, and as it goes up, it's just talking about each term. All right. You might need a calculator. You can use your phone today if you want. I got some right here if you want some. I'd like a calculator. Okay. Anybody? No. Anybody else? Or are you done?
I'm just checking just in case.
Okay, good.
Alright, I'm 100% sure about it.
Nice. I like that confidence. So, A sub 1,000. Actually, check with your neighbor. I'm just going to set this up, and then we'll do it together. What did you say?
It's 29. Oops.
I got 5,000.
What'd you get?
Boom. Easy peasy.
5,024?
Can we push it to like 10?
Wasn't it pretty easy to do 1,000? I thought it'd be more work. How about we do 1,000,000?
Oh, can we do like 1 billion? That's pushing.
Anytime we say something, you're going like a whole. If I say let's do 1,000,000,000, what are you gonna say? Oh man. Okay.
And then we'll do quatrain and so on and so forth.
That's right. 999 times 5. 4,000.
995. And then 29.
Whoops. Plus.
4,995 is 4,025.
So the 1,000th term. I actually thought it'd do more work than that, or take a little more work. I'm just curious now, and Simon's life will not be complete without this, so let's do 1,000,000.
Okay.
What are we doing?
Million.
1,000,000.
Okay.
What's the 1,000,000th term? Don't be intimidated. A sub 1 we know is 29. There's 1,000,000. Minus 1.
I got it.
Is that quick?
Yeah. It was actually really.
It's just what? Well, let's see. I think it's like you're saying that this is going to kind of work out the same way that did, and you're just adding 29. Okay. Well, let's see, because we all want to know. Acquiring minds. 9, 9.
It's
999.
It's 5.
999.
Yeah. Can I put the answer?
Well, what's this right here? Do this.
Oh.
Uh-oh.
It's like.
There's 4,000,000 there. I don't know.
You're there. You're there. 4,999,995.
5. Yeah.
Okay. Plus 29.
5,024,000.
5,000,000 and just 24.
No, 5. 50. Ooh.
Like that.
It's 5
50
million.
Yeah.
50 million.
That's it?
No, it's not.
It's 5 million.
No.
It's 5 million.
Wait, that's
It's
too
5
many.
million.
That's with too many nines.
Yeah.
499.
Well, think about it. You're right before 5,000,000. You go up 24, you're going to be 5,000,000 some change.
Where'd you get 50
Wait,
million?
hold on. 1, 2, 3.
Simon, did you do a trillion?
Probably.
No, I read it wrong. It's fine.
Okay. So, was that way easier than you thought it would be? Actually, I thought that
Can we
was much
push
harder.
it again?
What do you want?
1,000,001.
1,000,001 would be 5,029,000.
1,002,000.
5,034,000.
1,003,000.
I'm stopping there. All right, you guys feel confident? You could find any term you want anywhere. Yeah? Okay. It's good. Thumbs up, sideways, down. How do you feel? How do you feel about it? No, that's good. Saw some shifts. All right, that's excellent. You guys did great. The classwork, the classwork is in the workbook and the book because some of these are really quick. You can see how these are going to be quick problems. So I want you to get enough practice. You got 15 problems, and you have in class right now about 25 minutes. So that might get you through it. All right, let's go.